Now that we've centered the position of the wheel using mates and defined that with our assembly, let's go ahead and add mates to our pin component to define its position as well. I can launch the mate icon from the assembly toolbar in the command manager, or you can simply press the S key on your keyboard to bring up the shortcut bar and click on the mate icon here as well. Mates are just like relations, and you can define them in a lot of different ways based on your design intent. In this instance, for this pin component, the first thing I'll do is select the outer cylindrical face of the pin, and then I will select the inner circle, inner cylindrical face of the bracket. If for any reason you make incorrect selections, you can right-click here in the Mate Selections box and choose Clear Selections. Or, if you select a single selection, you can right-click and click Delete. And now you can choose a different selection, such as selecting this face instead. Our first selection was correct, so I'll choose that again. And for mate type, I'll choose concentric. Notice what this does. The pin is aligned correctly with the holes of the bracket, but it is still free to move. I will launch the mate tool again, and this time we will define its location. One way to do this is to first select the inside hexagonal face and then select the outer face of the bracket to create a coincident mate between them. Again, you can use the flip direction icon if the mate is backwards. I will go ahead and undo the mate to show you a different way to mate the two components. While we chose two faces earlier, notice that we can also select the inside edge of the pin and the outer face of the bracket using a coincident mate. This time, we have less mating options, but either way, we will end up with the same result. A pin that is free to rotate still, but otherwise unable to move within the assembly. We can choose to add one mate to lock down the rotation, so let's do that. I'll again launch the Mate Property Manager, but this time, instead of choosing a reference plane, I'll simply choose this face. Remember that the mates that you add can be very particular to your design, and it is up to you to decide which mates are necessary with your design intent. I'll then select the right plane, choose the parallel mate type, and click OK to apply the mate, and once again to exit the mate selection window. You can now see from the Feature Manager tree that the pin component is fully defined, and if I try to move or rotate it, I am greeted with the message which states that the selected component is fully defined and cannot be moved. I'll go ahead and rename this mate to Pin Rotation. And I will suppress it as well. Notice with the mates suppressed, the components go from being fully defined to underdefined. But when you unsuppress them, they become fully defined again. This is a good way to tell visually from your assembly tree which components are free to rotate still and which have components that have been fully locked down. And here you can see our assembly, and you can see that the mates have limited the degrees of freedom where the wheel and pin components are both free to rotate.